Dear students, I welcome everyone for this video session on transient response of series RL circuit fed with DC supply. Before starting this video session, I request all of you to watch my previous video on the basics of transient response so that it will be easy to follow this video session. In this video, we will discuss about the transient response in a series RLC circuit when it is fed with DC input. We will be deriving an expression for the transient current in the RL circuit, followed by some problem solving with related to transient response in series RL circuit. Consider an RL series circuit is connected across a DC input with the help of a switch, and when the switch is open, there is no current flowing in the circuit, and the initial current flowing in the inductor is assumed to be 0. So for this circuit, let us derive the expression for the transient current when the switch is closed with the help of Laplace transform. The final expression or the complete solution consists of the transient response plus steady state response. Assume that the switch is closed at t equal to 0. So what will happen? This input supply will start to send a current through the circuit, and as already we discussed in the previous video, that current in the presence of an inductor, the current cannot instantaneously increase to the steady state value. Instead, it will slowly rise. So in order to derive the expression, let us write Kirchhoff's voltage equation for this loop. So it will be V of t minus the voltage drop across the resistor is R into I of t, then minus voltage across the inductor is L into di of t by dt, which is equal to 0. Just rearrange the terms. We will get R into I of t plus L into di of t by dt equal to V of t. So from this expression, we are interested in finding the value of I of t. So for this, we will take the help of Laplace transform. So taking Laplace transform on both sides, we will get R into I of s plus L into s I of s minus I of 0 equal to V by s. This is a constant, and hence constant, when you take Laplace transform, it will be V by s. And the Laplace transform of this term we have already discussed in the previous video. It is s into I of s minus I of 0, where I of 0 is the initial current that is flowing in the inductor at the instant of closing the switch. So at the instant of closing the switch, the current through the inductor is 0, and hence we can make this as 0. So this term will disappear, and you take I of s common and bring this R plus Ls to the right hand side and make the denominator into s plus a format so that inverse Laplace is possible. Therefore, take the coefficient of s to the outside, and we can take L to the numerator. So it is V by L by s into s plus R by L. Now we take the help of partial fraction. So this can be written as a by s plus b by s plus R by L, from which we need to find the values of a and b. Hope you have already done all these things in maths subject. So you can rewrite this expression, cross multiply this, and both the denominator gets cancelled. Therefore V by L will be equal to this term. So from this, if I substitute S is equal to 0, this term will disappear, and hence V by L is equal to A into this much, and from which I can find A, which is equal to V by R. Similarly, if I put S equal to minus R by L, this term will disappear. Therefore, from which I can find B is equal to minus V by R. Now substitute the values of A and B here. I will get IFS is equal to, instead of A I will write V by R, and instead of B I will write minus V by R. So this much. Now it is easy to take the inverse Laplace because we are interested in finding I of t. You can take V by R outside and write 1 by S minus 1 by S plus R by L. So what is the inverse Laplace of 1 by S? It is 1, and this is of the form 1 by S plus A. So inverse Laplace will be e power minus AT. Here in place of A there is R by L. Therefore taking inverse Laplace, we will get I of t is equal to V by R into 1 minus 1 by e power minus R by L into t. This can be rewritten as e power minus t by tau, where tau is called as time constant, which is equal to L by R, just the reciprocal. So this, I already told you that the final expression will be consisting of steady state part as well as transient part. So V by R is the steady state part, and V by R into e power minus t by tau is the transient part. And if I draw the transient response with respect to this equation, I will get a waveform like this. This is the instant at which the switch is closed, so the current started to increase slowly and reaches the steady state after a time period which is determined by this time constant. So this transient period depends on the values of L and R. So please remember this formula, and based on this discussion, let us try to solve a problem. 30 ohm resistor and 15 Henry inductor is connected across 60 volt source. Now we are trying to find the transient current. So just try to follow the derivation what we have derived earlier. Apply Kirchhoff's voltage equation. We can write this expression and rearrange the terms. Take Laplace transform. And what is the initial current? The switch was initially open, so at the instant of closing there is no current flowing in the inductor, so the initial current is 0. So we can make this 0. So from this, take IFS outside and bring this 30 plus 15s to the right hand side and make this denominator into S plus A format by taking the coefficient of S outside, and using partial fraction we can find the values of A and B by substituting the respective values for S. A and B are found to be 2 and minus 2, so substitute those values here. We will get minus 2 by S minus 2 by S plus 2. Take 2 outside. Now inverse Laplace. We will get 2 into 1 by S minus 1 by S plus 2, where 2 into 1 minus e power minus 2t. This is the transient current that is flowing in the circuit after the switch is closed. Now in addition to this transient current, we are requested to find the values of voltage across resistor and capacitor, or sorry, inductor. So the voltage across resistor is simply I of t into R. So this is I of t, multiply the value by R. So 2 into 30 will be 60. This is the voltage across the resistor after the switch is closed. And voltage across the inductor, we know it is L into di of t by dt. So the value of L is 15 henries. D by dt of this I of t. So differentiate this with respect to t, and that is your final answer. The voltage across the inductor is 60 into e power minus 2t volts. Thanks for watching this video session. In the next video, we will derive the transient response of an RC series circuit fed with the DC input and continued by some problem solving. Thank you.